You're watching. Okay. So you'll give me your email, because remember I gave you for gold, I gave you gold. Yeah. So later on, just give me your email so that I have a record of it. So let's proceed. In terms of provisioning, before we proceed, I need to reset the questions. Yeah. So when you talk about provisioning, it will depend on two devices, right? Whether the device is a host or a CPE. So for hosts, the host will need IP addresses, IPv6 addresses. The host will need to know about the default gateway, right? And also know about DNS information, right? So what's the DNS server to be used? If it's a CPE, CPEs will also need IPv6 addresses, right? CPEs will also need the default routers. Routing needs to be done properly, DNS, and also in addition to that, something that's new in IPv6, the delegated prefix. So remember the conversation yesterday we were having about issuing a customer a /60. So you'll be doing that via what we call DHCPv6 prefix delegation. You delegate a prefix to a CPE. So remember in IPv6, that's not, in IPv4, that's not possible because you don't even have enough space, right? But in IPv6, you can be able to give a prefix to a customer. And most of the time should be for home users, right? You can give them a prefix. So we have the first Menti of the day. Today we don't have a lot of Mentis quizzes. I think I only have 2 or 3. But the same rule applies. Top 3 today, you also get an offer from me for the gold. So head over to menti.com. I will share the joining instructions on the screen. So menti.com, and then the code is 33703240. Yes. So what happens when he ends up being top 3 again? What should we do? So if you end up being top 3, we'll see. Let's see first what happens. Or you're too confident you'll be top 3, eh? Okay. So let's see. So menti.com, the code is 33703240. So if we are ready, I'll start it up. Okay. So most of us, we got it wrong, huh? And we talked about it yesterday when we said that it doesn't make sense for hosts on the network, connected to the network, to learn about the default gateway from another device, right? Why can't the device connected to the network inform the host that it's the default gateway, right? So that's what were the improvements that were done in IPv6. In IPv4, you set up the DHCP information on the default gateway information on DHCP, right? If you've configured DHCP before on IPv4, right, you'll specify the pool, also the default gateway, and this information will be sent to the host, right? But in IPv6, the default gateway is learned via your device will send a router solicitation, and then the router on the link will send back a router advertisement, right? So it's never learned via DHCP-v6, right? So I hope this is clear, right? So this is false. I hope you didn't, you see some of these questions sometimes if you're in a hurry and you don't read it properly, you will say true. If you don't read the question well, you get the point, right? So maybe you selected true thinking that we're asking something else, right? But the answer is false. Okay. Yeah, so that's the leaderboard so far. So Bahati was the fastest. I hope you're not Bahati. Yeah, so in terms of provisioning, remember provisioning is you are giving or issuing addresses and prefixes to either hosts or the CPEs, right? So there are two mechanisms. First one is Slack or the stateless address auto-configuration. Slack is based on RAs, right? The router advertisements. So the router advertisement, it always starts with the router solicitation, and then a router advertisement is sent, and inside the router advertisement, there's a prefix, right? And based on that prefix, your devices auto-configure themselves with an IPv6 address. So that's Slack, the RA-based Slack. And then there is DHCP v6. So for Slack and DHCP v6, they can both issue addresses, right? Slack can also issue DNS, same as DHCP v6, DNS information. And then Slack does not give the default gateway. It's the quiz we just did, right? Slack gives the default gateway, but DHCP v6 does not, right? DHCP v6 cannot issue the default gateway, but that's done via the router advertisement, right? That is sent. And then in addition to addresses, DHCP v6 can also issue delegated prefixes, right? So when you talk of delegated prefixes, think of this as the /60 or /56 we saw when you're doing your address planning. And then other information can also be issued via DHCP v6. So when you compare the capabilities of all these methods of provisioning, so Slack can give addresses. Slack also provides the default gateway, but it cannot give DNS information and the delegated prefix, right? So we have what we call stateful DHCPv6. Stateful DHCPv6 can give addresses. It cannot give the default gateway, right? It can give DNS information. It can also give prefixes. So yesterday, there was a question about knowing who has what IPv6 address. And I said that you either choose to do it automatically. With Slack, Slack is stateless, right? It does not store state. But DHCPv6 can be stateful, especially if you're giving addresses, right? Stateful means that you can be able to identify the devices that got addresses, right? You can have that log of address issuance or the leases, right? But with Slack, you can't do that because everyone gets a prefix and just configures an address. So it's important if you have reasons to have logs of IPv6 address issuance, then the only option that you have is stateful DHCPv6. If you don't have that requirement and you just want to deploy IPv6, make IPv6 available to certain VLANs or segments of your network, then you use Slack, right? Yeah. One important thing to note with DHCPv6, because if you know how DHCPv6 works, even generally DHCP, right? You'll have the DHCP client and server, right? So your laptop is a client, and then you're going to have a server somewhere. So the problem with the DHCPv6 is on Android, you don't have a DHCPv6 client, or basically, Android does not support DHCPv6 yet, right? So you see there's a challenge there, right? If you have people joining the network with Android devices, they're not going to get addresses, right? So it means that you need to do something else. Either Slack, right, is your only option to cater for mobile devices, people who have Android devices. So that's something to note. And then stateless DHCPv6 only gives DNS, right, information. And we'll look at this in a short while. And then you have the recursive DNS options in route advertisements. This one also gives DNS information only. So we have another Menti. Yes. Yes. So Slack on its own, right? So Slack meaning, whenever you talk about Slack or the stateless address auto configuration, that's the route advertisement. But there is usually another option we call the recursive DNS search list options or something like that, RA options, which can also be used to send DNS information via the route advertisement. But this option is dependent on the operating system, right? So it's not there by default. Huh? It should? The one that you have? Yeah, so the DNS config is not automatic, right? So that's why I said the DNS config is dependent on this last option here, right? So Slack on its own just gives a prefix, right? But you can be able to extend it by also including the DNS information in the router advertisement. Yeah. But Slack, when you talk of Slack, stateless address auto configuration, it's just a prefix being sent, right? It does not have any DNS information. But you can also do some additional configurations to have the DNS information being sent via the router advertisement. So I'll also show you some packet captures with the prefixes.
Is this in respect to the host and the CPE?
Yes. So this is in respect to the host, and for most of this is related to the host, right? Because the host will be getting, when you talk of Slack, first of all, this is related only to host, right? That's Slack. For DHCPv6, CPEs will be getting prefixes in addition to, if you know, maybe some of us will do it if you run a broadband network, right? When a CPE is connected, it needs the wide area network address, right? To connect to your network internally. Once it's connected, authenticates, then you send the other information like the prefixes and addresses to be used. Yeah. Any other question? To decide what?
Just particular use cases for all these methods.
Mm-hmm.
Is it possible to just give use cases, particular use cases for all the, just for clarity?
Okay. So for Slack, the use case is if, let's say, we are connected to this current network, right? And currently we have IPv4, right? So for you to give IPv6, remember, it all starts with the planning, right? You have to determine a /64 that's going to be used in various VLANs, right? So on this network, the admin will have configured a /64, and we get a all of us will send a router solicitation when you are connected to this network, right? When you just connect, the first thing that will happen is your device will send out a router solicitation. From the router solicitation, the router is going to respond back to you with a router advertisement. Inside the router advertisement, there'll be a prefix, a /64, right? All our devices will receive that /64, and based on that /64, we'll auto-configure ourselves with the last 64 bits. Again, if you have time, and if the labs were set up, we'll do a lab whereby you'll see how this works, right? On the interface where hosts are connected, you just configure an IPv6 address, and then when the host comes up, it sends a router solicitation, and then the router will send a router advertisement, and then when you check the IP config, you see a new address based on the prefix you configured. For stateful DHCPv6, you may decide that you don't want addresses to be issued automatically based on the router advertisement, right? And the other example, based on the question she asked yesterday, if you have the need to do logging of IPs that have been issued, right, in your network, then you need to set up a DHCPv6 server, and the host in the network will now be using the DHCPv6 server. You can decide to turn off Slack, right, and only be issuing addresses from DHCPv6. The third one here, stateless. Stateless DHCPv6, if you configure Slack, whereby the router on the link is sending router advertisements with a prefix, your devices still need to know DNS information. What's the DNS server that they're supposed to use, right? So to do that, you can set up stateless DHCPv6. So once your device gets an address, it also contacts a DHCPv6 server just for DNS information only. But in a few slides, we'll see all this, how it works, right? And it will be much clearer. Mm-hmm. Is it an option?
That you can turn off and on?
Yes, and prefix delegation only works when you're issuing prefixes to CPEs, right? It does not work like in this network where we are. You can't use prefix delegation. Get the point? So unless the admin sets up a DHCPv6 server and allocates prefixes automatically to various segments of the network, right? But most of the time, prefix delegation will just be used to allocate a prefix to a CPE. And most of the time, again, it's usually used in broadband networks, right? So you are a home user, you connect your CPE makes a request, and it gets a prefix assigned to it, right? A /60 or a /56. I don't know if it makes sense.
Yeah, I was asking because
Mm-hmm.
when you mentioned about the Android thing, I think as of 2026 that introduced that thing, but now I'm only saying if that option was also introduced, then
Mm-hmm.
Android can report very well with IPv6.
Mm-hmm. Yeah. Because I'm not aware of that. That's this year, right?
Yeah.
Which Android version, or you don't know?
I don't know exactly. I know that when you check on their website,
Okay. I'll check it out and see. Yeah. So any other question? Any other question? So if there's no other question, we have a Menti. It was active, huh? So the question is, which of these are flags in the route advertisement message? So I'll show the answers, and then we'll review it together. Okay, so most of us got it right. So we have the O flag, the M flag, the L flag, and the A flag. So this was the last question. So there was only one question which was timed. That's why the leaderboard was as it was. So who's Bahati? Okay. So I feel like the effort today was not that great. There was not too many questions, but anyway, it was still a promise, which I have to keep. So let me know. There is Bahati, there is Nick, and PM Ndaula. So reach out to me later on so that I capture your emails. So the flags. So flags basically tell the host what to do when they receive a router advertisement. That's the only thing to remember, right? We've been talking about router advertisement, right? And the router advertisement having a prefix. So again, if the admin in this network configured a /64 to the network that we're connected to, all of us will get a router advertisement, right? And inside that router advertisement, there will be a prefix. And there will also be flags which tell your device what to do, right? Or how to auto-configure itself. So there are flags in router advertisement messages, and there are also flags in the prefix itself. So the flag basically just tells the host what to do, right? So in the router advertisement message, you have the M flag of the managed configuration flag, and you also have the O flag. So when the router on the link sends us a router advertisement or sends your laptop a router advertisement and the M flag is set or is set to 1, right? So basically the router on the link is telling your device to contact a DHCP-v6 server. So M flag just means that when it's set, you are telling the hosts on the link to use DHCP-v6 to get addresses, okay? So what will happen? Again, you connect, your laptop sends a router solicitation. The router on the link will send out a router advertisement. If the M flag is set, your host or your laptop will receive that router advertisement and check the router advertisement and see that the M flag is set and telling it that it should contact a DHCP-v6 server. So the next step will be for your laptop to reach out to a DHCP-v6 server, and we'll look at that in a short while. But basically all you need to remember is the flags tell the host what to do, right? And I'll show you the packet captures. The O flag tells the host to reach out to a DHCP-v6 server for DNS information only, okay? So remember when you talked about stateful and stateless DHCP-v6, right? So M flag, this is stateful DHCP-v6. You are telling the host to reach out to the DHCP-v6 server for everything, right? Address plus DNS. O flag, this is stateless DHCP-v6. So you are telling the host only reach out to a DHCP-v6 server for DNS information. With stateful, like we said, the DHCP-v6 server is going to have a record of the addresses that have been issued, right? But with stateless, the DHCP-v6 server does not have a record because stateless, you're just sending DNS information, right? So there's no need to store the state. So those are the two flags inside the RA. And then inside the prefix, so when you get a /64, there's also going to be some flags, right? The first one is the L flag, which is the on-link flag. Then the second one is the A flag. So when the router advertisement is sent and there's a prefix inside it, the A flag is always set to 1 because you're telling the hosts use the prefix inside this router advertisement to auto-configure yourself, right? So you can also picture this. What if the M flag and the A flag are set to 1? What's going to happen? So we said M flag is you're telling the host or your laptop to reach out to a DHCP-v6 server to get its addresses, right? A flag, you're telling the host to use the prefix, the /64, in the router advertisement to configure itself with addresses. So if both of them are set to 1, what will happen? Anyone? There'll be a conflict. Do you agree? There'll be unspecified. No. Yes. It will consider. It will consider what?
Consider the M.
The M. So he says it will consider the M only. Anyone else? Mm-hmm. Yeah, exactly. So your laptop will have two addresses, one from DHCPv6, another one from Slack, from the prefix that was sent. Because remember, in IPv6, an interface can have as many addresses as you choose to configure, right? So in this scenario that we just talked about, your laptop will have two addresses, one from DHCPv6 and another one from the prefix. Yeah, actually, this is the next thing, right? So if you set the M flag to 0 and the A flag to 0, then no addresses will be auto-configured, right? If you set the M flag to 0 and the A flag to 1, addresses will be generated from the prefix sent inside the router advertisement. If you set the M flag to 1, A flag to 1, so the host will have two IPs, right? IPv6 addresses, one from the prefix in the RA and another one from DHCPv6. And then M flag set to 1, A flag to 0, then addresses will be from the DHCP server. Then also, for this to work, the option of to obtain IP addresses automatically on your laptops must be set, right? For all this to work, because that's what starts the whole process, right? Router solicitation, router advertisement is sent back. So let me share a packet capture to look at this. Yeah, so this is a router advertisement. So again, recapping what we did yesterday, you have the IPv6 header, version, payload length. The next header points to ICMPv6. The source address is a link local address. So based on this route advertisement, the host receiving this will know that the default gateway is reachable via that link local address, right? So that's why the default gateway is never sent via DHCP-v6. So the route advertisement is what tells the host about the default gateway, right? The destination address is FF02::1, right? So meaning that this route advertisement was sent out from the router, not in response to a router solicitation. I hope it makes sense, right? Because if your laptop sent a router solicitation and I did this packet capture, then the destination address will not be FF02::1. It will be your own link local address, right? So yesterday we said that the route advertisements can be sent in two ways, right? Either in response to a router solicitation. So if you connect your laptop to the network, your laptop is going to send a router solicitation, and immediately the router will respond with a router advertisement. That's method number one. Method number two, the routers on the link will always be sending router advertisements periodically. So every maybe 30 seconds or every 60 seconds, router advertisements are sent. So this is the example, right, of a router advertisement that was sent periodically. Under ICMPv6, we can see that this is a router advertisement. So this is a router advertisement. And the flags we were just talking about, right? So the flags are here. So let me expand that. So in the slides, we talked about two sets of flags, right? There are flags inside the router advertisement, these ones here. And then there are flags inside the prefix, okay? So let's start with the router advertisement. And like we said, the flags will tell the hosts how to auto-configure themselves, right? So here, we have all the flags are set to 0, right? Manage configuration is not set, other config is not set, right? For the rest, don't worry about that. This one is about mobile IPv6, but it was something that was being done in the 2010s, right? So all you need to worry about is these two here, the M flag and the O flag, right? So since it's 0, the host receiving this route advertisement is not going to use DHCP-v6, right? And inside the prefix, so down here we have the prefix information, right? ICMPv6 option, prefix information. So there is a /64. So if you receive this route advertisement, you're going to have an IPv6 address starting with this 2001 db8 BEEF blah 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 /64. You'll have an address starting with that prefix. And then inside the prefix, you have flags, right? 2 flags. So I'll expand that. So since we are sending the prefix, the A flag will be set to 1, right? So basically when the host receives this route advertisement, it knows that it should use this prefix to auto-configure itself with an address, right? And then the L flag, the on-link flag, is always set to 1. For the L flag, it determines whether a prefix is on-link or off-link. And to simply explain this, all the time, most of the time, or by default, the L flag should always be 1, because if all of us get the same prefix, we are on the same link, right? So it means that we should be able to reach each other or ping each other. But if for one reason or the other, the L flag is set to 0, you are telling the host that this prefix is off link, meaning that to have reachability to your neighbor connected on the same network, you need to go via a router to do that. So it enforces a behavior called private VLAN-like behavior. So each one of us cannot be able to reach each other even though we're in the same link, right? So that's the L flag. By default, it's always 1, but we've seen scenarios whereby it happened once where someone configured a prefix and there was no reachability between devices based on that same prefix. So after troubleshooting, we found out that, and also existing connections. So if you get a prefix and you want to connect to maybe youtube.com, so based on that prefix, that address will be used for new connections and existing connections. If this lifetime gets to 0, right, the address based on this prefix cannot be used for new connections, right? It can only be used for existing connections. So that's why yesterday I said you can do switchover of prefixes, right? So imagine this is your prefix, and then something happens and you want to do renumbering in the network, right? You want to change the prefix that is being used on this link. So there are two ways. Either you can just configure something new, but it means that there'll be a disruption in connectivity, right? If you introduce a new prefix, right? So what you can do is you can add a new prefix, but with longer lifetimes, right? And then reduce the lifetimes for this one that you want to remove. So it will be like, what's the word? The switchover. I'm forgetting the word that's normally used. When you have that seamless switchover, right? Is it graceful? No. This is a word that you have two prefixes. One will expire, if I can call it that, and then the second or the new one will start being used, and it will not be noticed. You'll not have any downtime. Yeah. So that's the use case for these lifetimes. Again, I really hope we have time. You can demonstrate this by the settings that are being done on the interface that the hosts are connected to, right? You can introduce a prefix. If you set the lifetimes to 0, for example, it's as if you're saying this prefix should not be used. And then when you check on the host, the prefix will be cleared. Addresses based on this will be removed, right? Hopefully we get time in the afternoon to do this lab. So any questions on this? Any questions? So of course, like I was just mentioning right now, this is how you do the configuration, right? IPv6, neighbor discovery, this is on Cisco, but it will be pretty much the same on the vendors that you have. Yes? Mm-hmm. So for them? Uh-huh. That's a really good question, right? Because if you get two addresses from Slack and from DHCPv6, what does the host prefer? So remember, Slack always happens fast, right? Slack will always happen fast because you send a prefix, and based on that prefix, the host auto-configures itself with an address, right? So ideally, your device should have the first address from Slack, from the route advertisement. And we'll look at this in a short while, because when the route advertisement is sent, it has the prefix, and then it has the flags, right? M and the A flag. Automatically, the host gets the flag, the route advertisement, it will configure an address. But before it configures the second address, it needs to reach out to the DHCPv6 server, right? So there'll be a small gap between the address it got from Slack and the address it's going to get from DHCPv6. Because once it gets the route advertisement, it needs to start contacting a DHCPv6 server, right? There are some messages that happen before it reaches out to a DHCPv6 server. So ideally, the host is going to use the address from Slack because it will be received fast, right? And then you'll also have another address from DHCPv6. But there are many algorithms that determine the address to be selected. Nowadays, all addresses will be randomly generated, the last 64 bits. If it was some time back, the addresses generated via Slack, if they had the MAC address, they will not be preferred. You get the point, right? Usually you'll prefer temporary addresses over addresses generated via the MAC address. But on paper, you should use the address generated from Slack because there's an additional step to get the second address from DHCPv6. Yeah. Any other question? Yes.
I just want to briefly go back to that part of value timing.
Okay.
Just explain it again.
Okay. So there was a slide. Let me show you the slide. I should. So this was a slide about the states of IPv6 addresses, right? So it always starts with an address being tentative. So even if you get an address from DHCPv6, it will not be configured automatically because duplicate address detection needs to be done for it, right? If you even think about it, even though it's rare to happen, there's a chance that someone can configure the same address gotten from DHCPv6, right? There's a chance. So that's why duplicate address detection is done, right? So if duplicate address detection fails and there's another device with the same address, then that address is marked as duplicate and it cannot be used, right? If duplicate address detection passes, that address is marked as valid. So valid addresses have two lifetimes, right? There is the preferred lifetime and the valid lifetime. So if the preferred lifetime is greater than 0, based on the numbers we saw, as long as it's greater than 0, that address is going to be preferred for new and existing connections, right? Okay, thank you. So if the preferred lifetime is greater than 0, that address will be preferred for new connections, right? To transmit and receive. If the valid lifetime is greater than 0, then that address is marked as deprecated as long as the preferred lifetime gets to 0, right? So I'll come back to the numbers, right? But as in a summary, the valid lifetime is usually bigger than the preferred lifetime, right? So let me show you the packet capture. So here, the valid lifetime is 259,200, 30 days, right? and the preferred lifetime is 7 days. Okay? So meaning that if the host does not get any other router advertisement, these lifetimes will not be updated, right? So after 7 days, this lifetime will get to 0, right? And then this one will be at 23 days. So what that means is that this prefix will not be used for new connections, right? But it can be still used for existing connections. If there are any existing connections, then this prefix will still be used. If the lifetime is greater than 0 when you get the RA, then this prefix will be used normally, right? So my point was, you can be able to manipulate these timelines to introduce a new prefix without any disruptions in connectivity, right? What you need to do is you send another prefix. Maybe if you want to do renumbering in your network, right? That's the most common use case for this. You have your first prefix, existing prefix, and then you introduce a new prefix, maybe BO00D. You want to renumber, right? You want to introduce a new /64. So you introduce two prefixes. The first one that you want to delete from your network, this one here, you tweak the lifetimes to be lower, right, than the new one. So you can change this lifetime to maybe 2 hours and change this, the preferred lifetime to maybe 30 minutes. So in 2 hours time, this prefix will not be valid anymore, right? And the new one, which has a larger lifetime, is going to be used by the host for connectivity. So usually valid lifetime is big, preferred lifetime is smaller, and preferred lifetime just means that the prefix is preferred for initiating connections, right? After the preferred lifetime gets to 0, if it ever gets to 0, then that prefix will not be used for new connections, right? Again, usually, I really hope we can do that lab because it always makes sense. When you play around with the timings, you get to understand it much better, right? Because usually, these timelines will depend on the router advertisement being sent, right? You can even set them to be infinite or something like that, whereby this prefix will never expire, right? You can decide to choose that, to do that. But anytime there's a new router advertisement that is sent, these timelines are always refreshed, right? Yeah. Does it make sense? Yeah. Any other question? Any other question or anything that's not clear? So again, I was talking about how to do the configs, right, on various vendors. So this is on Junos, setting the flags, right, and sending a prefix. On Mikrotik, same thing, right? So on the VLAN, you set the M flag, O flag, yeah. And then I just talked about the L flag, right? So I'll not repeat this again. Most of the time, by default, the L flag will be 1, meaning that hosts on the same network or on the same link do not need a router to reach each other, right? Because they're on the same link and they can communicate directly. And then off link, or if it's 0, it means that you need to use a default gateway to get to the host. So this is how you set the A flag. Basically on Cisco, anytime you configure an IPv6 address on the interface and you have hosts connected to that interface, then automatically hosts will be using that prefix to auto-configure themselves. But alternatively, you can send the prefix, right? IPv6 neighbor discovery, then you specify the prefix. So and then we have DNS. So for DNS, either you can set the M flag to 1, meaning that you're telling your laptops or the devices to reach out to a DHCPv6 server to get everything, right? IPv6 addresses plus DNS. And then you can also set the M flag to O, the O flag to 1, meaning that you're telling the devices, or you can picture your laptops, will get a route advertisement and they need to reach out to a DHCPv6 server only for DNS, right? Again, if the most important thing that you just need to understand, do you know the M flag and the O flag, what they do? The impact of setting those flags, right? On address configuration, right? You need to just be aware of that, right? Because I can give you a scenario whereby I show you a diagram and I show you a router advertisement message with the O equals to 1. So you need to remember, when you see O equals to 1, you just know that you are telling the host to reach out to a DHCPv6 server to get DNS information only, right? So that's very important for you to note, right? If you see a diagram and I show you M equals to 1, then you know that we are telling the host to reach out to a DHCPv6 server for its addresses, right? And DNS information. If you see A equals to 1, you are telling the host to use the prefix that is being sent in the route advertisement to auto-configure itself with an IPv6 address, right? So unless there's any question. So for DNS, yeah, this is what I was just talking about. M equals to 1, also O equals to 1, right? And then DNS can also be done via the router, but the host needs to support this RFC. I believe nowadays all operating systems have this support, right? Previously, you could not send DNS information from the router because most operating systems did not have that capability. Nowadays, they do. So if there's no question or any question, please review this. And if you have any question, you can ask after the break and even talk to me like I said, right? And I'll explain. So if there's no question, we can have a break, 20 minutes. So let's be back at 10:55. So as usual, upstairs, you'll have your break. A flag is set to 1. And you also have readiness information. So it always starts with the RS, right? And then the RA has information that the host is going to use to auto-configure itself. So some key things to note: when you set the O flag and the M flag is set, it's redundant, right? Because M flag, you're telling the host to contact a DHCPv6 server for addresses plus DNS, right? O flag, you're telling the host to contact a DHCPv6 server for DNS information, right? So it's redundant because M flag does everything, right? Yeah. Yeah, the most important thing here is that Slack works with /64. So if you decide to configure, maybe on that VLAN interface, on the interface where hosts are connected, if you decide to configure a maybe 96, for example, then you'll break Slack. Slack will not work. So a prefix will be sent, but the hosts cannot auto-configure themselves with that prefix. So it's always a /64, right? And then always test, right? Always test what happens in your network before actually deploying. So remember, we do training. So we do train, certify, and then deploy. So probably a few months from now, we may come back and actually start working on deployment. We call it a deployathon. So a deployathon is a 4-day event whereby we're not teaching. So we just work on prototyping how your network runs and then implementing IPv6 in your networks, right? Yeah. So hopefully maybe 3 months from now or a few months from now, we can come back and now do a deployathon. So based on your network. But some of the things we've discussed here, like address planning, you should sit down and create a structure or a plan for how you manage your prefix, right? If you don't have a prefix from Afrinic and you're an Afrinic member, make a request for your prefix, right? That's the first step. Step number 2 is once you have a prefix, advertise it via BGP, right? Step number 3, deploy IPv6 in your core, right? And backbone, ensure that you have IPv6, and then deploy IPv6 in the access network, and finally, customers. Deploying IPv6 takes time, right? Takes a few months or even years sometimes, right? But you do it slowly, right? Yeah. So always test. So this is how you configure Slack on Cisco. Again, this is a repetition. And on, yeah, so that's Cisco. But other vendors, it should be quite similar, right, to that. So second is DHCPv6. Again, it always starts with an RS, right? Router solicitation. The router sends back an RA, right? With the M flag set to 1, right? Once the host gets the router advertisement, it now needs to start reaching out to a DHCPv6 server, right? If you know DHCP in IPv4, you should know DORA, right? Who knows DORA? Not DORA a person, but there's the acronym DORA. Who knows DORA? It's what? You guys don't know DORA? Discover, offer, request, acknowledge, right? So DORA, discover. So the host will send out a discover message. The DHCP server will send an offer, and then the host will request, and then the server will acknowledge, right? So we have the same thing in IPv6. So once the router advertisement is sent, M equals to 1, the first thing that will be done is solicit. So in IPv6, the first message is solicit, right? Then the server will respond with advertise, right? So it will advertise some options, an address plus DNS information, right? At this point, when the solicit is being sent, there is a chance there may be more than one DHCP-v6 server, right? So that's why the advertised message is sent. Even in IPv4, it's the same. So that's why the offer message is sent, because the offer message can come from multiple servers. So the host will now pick or accept that address and request it, right? Send a request to the server that I'm okay with this address. So request is the next message, right? So solicit, advertise, then request, and then the server will send back a reply message, right? Confirming that this IPv6 address can be used or configured. So after this, what happens? When the server sends a reply message, what happens? What is that? The reply is the last message, right? Because it starts from solicit from the host. Then the server will send an advertise. And then the host will request that IPv6 address. And then the server sends the final one, which is the reply. So at this point, the host is ready to configure that IPv6 address. But there's something that needs to happen, which is there's one more step before the address is actually confirmed, right? Before this is done at the top, there's one more step. Yeah, that, right? Duplicate address detection needs to be done for that address before it's actually configured. So same thing with stateless DHCP-v6. It always starts with an RS. And then with stateless, what will be in the RA? Which flag will be set? Stateless DHCP-v6. O will be 1, right? So this will be, you are the one who's actually going to configure on the router, right? You'll do the configuration so that when the RS is received, the RA will be sent with the right option. So in this case, for stateless DHCP-v6, the RA will be sent back with the O equals to 1. And since the host needs addresses, you also need to ensure that the A flag is set with the prefix, right? So in this case, the host is going to auto-configure itself with an address and also configure DNS information. So for DNS with the O flag, it's much simpler in terms of the number of steps, right? For an address, remember again, as a recap, solicit, advertise, solicit from the host, advertise from the server, request from the host, reply from the server, right? 4 messages. But for DNS information, because you just want to know the DNS server, right? So they will only send 2 messages, which is the information request sent to the DHCP-v6 server, and then the server just replies with the DNS information. So it's much simpler. So this is how you configure DHCP-v6. Again, you have the slides, you can check it out. But the most important thing is, on the interface, you need to enable the M flag or the O flag. You need to actually do that configuration, right? So the last one in this section is prefix delegation. Again, it follows the same line, right? But with prefix delegation, we said you are delegating a prefix, right? To most of the times CPEs, right? So first thing that needs to happen with the CPEs, you'll need to provision the WAN address, the wide area network address, for communication for your internal devices. And then the next thing that will happen, is the solicit. So the CP will send out a solicit message. The server will advertise a prefix. Then you'll have the request and then a reply. And this time around, we are sending a prefix, a /60, not an address, right? A prefix. So that's prefix delegation. So this is how we configure prefix delegation. Yesterday we did the subnetting, breaking it down, right? With the example we did, we saw that we needed /44s to get /56s, right? So when you're doing the actual config, you'll configure a pool. You see in this example here. So in this example, the pool is a /40, and we are getting, or we are sending out /48s, right? We'll be delegating /48s. In our example, you'll have done the pool as 44, and then you delegate 56s, right? Or 60s, depending on what you want to achieve or what you decide in your network. So any questions up to this point? Any questions or anything that's not clear? Yes. Mm-hmm.
So say we configure an IPv6 /60 from the database. So after configuring it, we still need to also configure delegations on the CPU. And it just work like without delegation.
So the question is, here on prefix delegation, right? So the question is, can't the CP have connectivity without doing prefix delegation? Because here we say that the first thing that needs to be provisioned is an address for the CP to communicate internally, right, with the provider's network, right, which is usually a /64. And then in addition to that, you need the delegated prefix, because the delegated prefix will now be used internally. So let's say if you're at home, you'll need the prefix to be used internally. Usually, when the prefix is delegated as /60, usually 1/64 is configured automatically on one of the VLANs, right? Because the customer, like we said, most customers, we don't expect them to be using these prefixes. They just want the internet to work, right? Yeah. So they don't care about this IPv6 or all these things, right? So as long as the internet is working, that's what they care about. So usually, you will send a /60, delegate a prefix as /60, and 1/64 will be used internally, right? So even the example I've been giving is the network we're connected to right now, right? So 1/64 will have been configured for us here to be used internally, right? And then if a customer is technically inclined and they want to do other things, they can now configure different VLANs with the other /64s that they have, right? Yeah, but the one address, that address that is issued first, is just for the CPE to communicate internally. Yeah, and then behind the CPE, now inside the network, customers need to have IPv6 connectivity. In IPv4, you don't need to do much because you always get a private IP, right, internally. But in IPv6, you now issue or delegate a prefix internally. most of the time, or typically, one of the /64s will be configured automatically so that the internet just works, right, for the customer. Then if they choose to, they can have other options for VLANs and other /64s, which they can configure. Any other question or any clarification? Yes.
So, when addresses from the DHCP server, so is it upon maybe the administrator to specify whether we are going to use UI64 or maybe we are going to randomly generate the address identifier?
Yeah, so that's a good question because it will clarify a lot of things. Because he's asking whether the address issued via the DHCP-v6 server, you also need to do EUI64. Remember, from DHCP, you're getting an address, full address, 128 bits. But with Slack, the one whereby you use the prefix in the router advertisement, you're only getting a prefix as /64, and then your device decides how to fill in the last 64 bits, right? So with Slack, that's where the issue of EUI64 comes in. But nowadays, like I said, most devices will not use EUI64. It's always randomly generated, right? Yeah. So DHCP gives you a full address, 128 bits. But Slack or the router advertisement gives you a prefix, which then your device auto-configures itself with an address based on that prefix. Hope it's clear. Yeah. Any other question or clarification? So the next section is routing. And like I said, these sections are very short because routing in IPv6 is not that different from routing in IPv4, right? The only difference is the protocol and the versions of the routing protocols need to support IPv6, and you need IPv6 addresses, right? But routing is really straightforward in terms of IPv6, similar to what you do, but the only difference is the protocol and addresses, right? So as usual, the principles of routing in IPv4, we know this, we should know this, right? The longest match on the destination prefix will always be preferred, right? So if you have an IPv4 prefix or address that is /28, for example. So we'll always prefer the longest match as opposed to a shorter prefix, right? So a /28 will be preferred as compared to a /24, for example, right? Realistically, since the prefix size that should be seen in BGP is a /24, right? So a /24 will be preferred compared to maybe a /23. I hope you get the point. The longest prefix match always wins, right? Same thing applies in IPv6. Yeah, and then we have the issue of, we know about static and dynamic routing, right? We should know this, right? Static versus dynamic. Static, you do the routing manually, right? IPv6 route, you point to the route via this next hop. Same thing applies in IPv6. Same concept of administrative distance, right? So what's the administrative distance? Here we say it's the degree of trustworthiness, right? So who knows or who remembers administrative distance? What's the function of the AD? So let's start by asking, what's the administrative distance? It's a number, right? So let's say OSPF. What's the administrative distance of OSPF? 1 110. The administrative distance of eBGP is, who knows? 20. So basically what that means is if you have a route learned from two protocols, one from BGP and another one from OSPF, you're going to prefer BGP because of the administrative distance, right? BGP's AD is 20, right? OSPF is 110. And always when you're doing routing, we always prefer to send packets outside, right? So that's why eBGP has a lower or preferred administrative distance. Lower is always preferred, right? If you do a static route, what's the administrative distance of a static route? 1, right? Yeah, it's because you are manually specifying the route, right? Yeah, so static will always be preferred. Then there is BGP. eBGP is 20. But I know on Huawei it may be different on some vendors. Yeah. And then OSPF is 110. EHRP is 90. Yeah. ISIS also has its own administrative distance, right? IBGP also has its own administrative distance. So you prefer eBGP versus IBGP, right? Yeah. And then the concepts of distance vector, link state, we should know this, right? Distance vector hops, right? Link state, cost. OSPF, you're looking at the cost of the links, right? Yeah. So in terms of best practices, again, this should be things you're doing in IPv4, right? And that's why I keep on insisting routing in IPv6 is not much different from what you do in IPv4. So for IGPs are the interior gateway protocols, right? Your OSPFs, your ISIS. So IGPs are only used to carry infrastructure addresses. So for your internal network, you have your core routers, etc. So IGPs, your OSPFs, and ISIS is just only used for reachability for all your internal devices, right? So IGPs should not carry customer or internet prefixes, right? So who knows the current IPv4 BGP table? How many prefixes does it have? The full table. If I was to send you the full table, how many prefixes does it have? Who knows? Those who do BGP, anyone with an idea or rough guess? Any idea? How many prefixes does it have for v4? So no one does BGP here. If you're receiving the full table, or we get default routes from our upstreams. So it should be around 1 million, right? 1 million routes in the full BGP table, right? So you can picture having 1 million routes inside OSPF. It does not work, right? There are too many routes. So that's why the IGPs should never carry customer or internet prefixes, right? So for those prefixes, customer prefixes, they should be carried inside IBGP, right? Across your backbone. And then eBGP will be used to exchange prefixes with other networks, right? So let's say you have your own autonomous system, and then you do a BGP session with another autonomous system. So eBGP will be used to exchange prefixes in between your networks. So again, I'll not spend too much time here. This is an example of static routing, right? Whereby you're manually specifying a route, right? From that router to the other router, or from that network to that network on the right. So next one is OSPF. So for IPv6, we have what we call OSPF version 3. And with OSPF, we have two versions of OSPF, right? Because when OSPF was initially developed, it was not extensible by default, right? So that's why we have OSPF version 3 and OSPF version 2, right? When you look at ISIS, we don't have an ISIS version for IPv4 and another one for IPv6. ISIS is just ISIS, right? Because ISIS is extensible by default, right? So it was developed way back, long time ago, but it's able to, you can be able to extend it with new features, right? Same thing with BGP. We don't have a BGP for IPv6 and then a new one for IPv4. We don't have a BGP for IPv4 and a new one for IPv6. I hope you get the point, right? But with OSPF, we have two versions of OSPF. Version 2, which only runs IPv4, and version 3. But the key thing is with version 3, you can run both v4 and v6, right? So the most important thing to note here is OSPF will operate per link and not per subnet. And same concepts apply, right, as OSPF version 2 for IPv4, right? So for example, for neighborship to be formed, we had, there are several conditions that need to match, right? The most common one is the timers, right? If you remember the hello and the dead timers, right? So if you configure the hello as 10 seconds on one router, it needs to match the other router, right? If there's a mismatch, then neighborship will not be formed, right? Yeah. And then the dead timers should be the number of times you miss the hellos, right? Usually it's 4 hellos, or in other words, 40 seconds, right? So if after 40 seconds you don't get a hello message, then you consider the neighbor to be down, right? Yeah. So same concepts apply. What you just need to remember, if you don't get anything from this, right? There are two things you need to remember. There are two new LSAs. LSAs stand for link state advertisements, right? So there is usually type 1, type 2, type 3. So all these are the same in IPv6, right? The router LSA, which describes router links, network LSA, inter-area prefix for ABRs, the area border routers, and then the autonomous system border routers. So again, we assume you know this, right? Or have an idea. But like I said, if there is one thing you just need to remember from all this, is that OSPF introduces two new LSAs, right? The link state advertisements. There is the type 8, the link LSA, since OSPF operates per link, right? So the link LSA will advertise link local addresses, right? And then there is the intra-area prefix LSA, which will be used to advertise IPv6 prefixes inside OSPF. Okay, so again, I know most of us probably we don't work with OSPF, right? But you just need to have a rough idea on this. And the key takeaway from this, you can even take down some notes, right? These two things here, the two new LSAs in OSPF, the type 8 and type 9 LSAs, link LSA and also the intra-area prefix LSA. So any questions? So again, I'll not spend time going through each of these commands. In case you configure OSPF or you deal with OSPF, have a review of how it's configured, right? Yeah, you specify the area, yeah, and then the prefixes, etc. But I'll do a small recap, right? So in this scenario here, we have area 1 and area 0, right? So this router, router 2, is called what? What's the name of this router? ABR, right? So the area border router, because it's in two areas, right? So the interface on the left, on my left, is on area 1, and then this interface, F1/0, is in area 0, right? Yeah. So if you're to configure this is the configuration you'll do on the router, the ABR, right? So you have how to configure the IPv6 address, place the interface inside area 1 or area 0, place the other interface inside area 1, and that's it. Same thing with the other router. Yeah. You initiate OSPF, configure the v6 address, place the interface inside area 1. Same thing with the other router, same thing. And finally, router 4. So again, as a summary, remember the purpose of OSPF is to carry your own infrastructure addresses, right? So if you are here, you should be able to have connectivity to router 1, right? Or from router 1 to router 2, yeah. And then on top of OSPF, most of the time you'll be running, for most people they run IBGP, right? Yeah. So any questions on that? So for BGP, the first thing that we mentioned, there is no BGP version 6, right? It's just BGP version 4, right? So you just need to remember that BGP version 4 doesn't mean it's BGP for IPv4, right? And like I mentioned, BGP was or is extensible in nature. So what was done, instead of creating a new version of BGP for IPv6, the current version of BGP was extended to support IPv6 via the IPv6 address family, right? And you can extend BGP to, it was extended to support the VPN v4, VPN v6 address families and many other address families, right? And then the other most important thing is IPv6 can be both the payload and the transport protocol. So basically it can be what's being transported and also what's been configured. So I'll show you the example now. So you can set up the BGP sessions in various ways, right? The first way, which again is not recommended, you can have BGP speakers, IPv6, communicating over an IPv4 session, right? So right now, if you are running BGP on IPv4, right, you can be able to send IPv6 over IPv4, but it's not recommended, right? Because for that to happen, if you're sending IPv6 over IPv4, you need to change the next hop, right? Because the next hop obviously will be IPv4, right? The other way you can do it, you can run IPv4 over IPv6, right? Which is also not recommended, right? So you have an IPv4, IPv6 session, and you send IPv4 inside IPv6. It's not recommended. So what's recommended and what many people do, and what we expect you to do is you create 2 sessions, right? One session for IPv4, which you should already have if you're running BGP, right? Then you create another session for IPv6. So typically, what happens is you're going to make a request to your upstream, right? Because you already have a BGP session in v4, and maybe they're sending you a full table or maybe a default route, right? So you need to make a request to them to give you BGP sessions, right? And normally, they will give you an address to configure on your side, right? An IPv6 address for the point-to-point link, right? And they configure an address on their side and then create the session, right? But this is what is recommended. You do a session for IPv4 and another session for IPv6. So with this in mind, you can also see that these 2 protocols are independent, right? If you set it up this way, if there's an issue with IPv6, then it will not affect IPv4, right? And the analogy I always like to use is for you to picture IPv4 and IPv6 as 2 separate pipes, right? On day 1, we said that IPv4 cannot talk to IPv6, right? Because the headers are different, the addresses are different, right? So for what I usually recommend is for you to picture those protocols as two separate pipes. There's a pipe carrying IPv4 traffic and packets, right? And there's another pipe carrying IPv6 packets. So if something happens to the IPv6 pipe, the IPv4 pipe is still running, right? If something happens to the IPv4 pipe, the IPv6 pipe is still running. So usually people are afraid to deploy because they think that when you deploy IPv6, you're going to impact IPv4, right? But these two protocols are independent, right? And also in terms of, let's say, resource utilization, people always think that if you deploy both IPv4 and IPv6, you're going to have double resource utilization. It's not the case, right? So let's say if your memory usage is at, let's say, 25%, it does not mean that when you enable IPv6, it's going to jump to 60%. No, it doesn't work like that, right? Of course, there will be a small change, but it's not double, right? Yeah. So that's something to note of when you're deploying IPv6. Yeah, so this is a sample config of BGP, right? On Cisco, but on other vendors should be quite similar, right? You enable unicast routing, specify the neighbor. So this is V4, the remote AS, and then do the same thing with V6, right? And then once you do that, you activate the neighbors and send the prefix, right? So neighbor, activate, send the prefix. V6, the same thing. Activate the neighbor, send the prefix, /32 or /48. So any questions on routing? Can you share? You have a slot?
Yep.
Okay. Thank you. Any questions? So the last thing we look at, the last topic we'll review is transition techniques. So with transition techniques, at our level, I'll just do a rough overview, right? For those who've been able to take the courses, e-learning courses, you'll notice that the e-learning courses are very wide on this topic especially. It's very wide and it covers a lot of things, right? But for our level, we just need to know the basics, right, of transition techniques. So I'll ask you a question. Is it migration or transition? It's a transition, migration, transition. Yes. Both. Yes. Transition. So why transition? Why do you say transition? Because you're not? Yeah. So we're not like removing IPv4, right? When you say migration, you can migrate from Windows 10 to Windows 11, right? So you're moving from one version to another. You can migrate from Server 2012 to Server 2016, right? So you stop using Server 2012, you move to Server, you deploy Server 2016, right? But usually, most people confuse the two, right? So when you say we need to migrate to IPv6, basically you're implying that you need to move away from IPv4, leave IPv4 alone, start doing IPv6 only, which is never realistic, right? It can never be the case. So from today, henceforth, since you guys hopefully will be certified engineers, we should be using the term transition, right? So don't be saying, yeah, we need to migrate to this new protocol. And if I hear someone saying IPv6 is new, you'll embarrass me a lot. That will be, we need to migrate to this, you know, there's this new protocol we need to start deploying. IPv6 has been around since 1997, right? So IPv6 is not new. But yes, of course, it had challenges in the 90s, in the early 2000s. But the more people are deploying, they realize there are issues, and then those issues are fixed. So right now, you can say IPv6 is more mature as a protocol, right? So of course, it still has issues. It's not perfect, but it's more mature, and it's something you can deploy, and people are doing it, right? So the reason why we need transition techniques is, first of all, IPv4 only content, right? So if I'm in an IPv6 only network, I cannot access content that is on IPv4 only, right? Yeah. And I think maybe 90% of us in this room, our content is IPv4 only. True or false? Or even 100% of us. So if I'm on an IPv6 only network, can I access your website? If I'm on IPv6 only network, can I access your website? UCC or Renu or who else? Roque, C squared. Huh? Yes, you can. You can't. So you can even check when you do a dig. So if you do a dig and then maybe Renu dot whatever, you should get back the code A record, right? If not, then someone in an IPv6 only network cannot access your content, right? So what we usually recommend, right? Because people use transition techniques to access content that does not have IPv6, right? If your website has IPv6, then someone will not have the need to use a transition technique because they can still access your website, right? So always ensure, at least, even if you're not deploying IPv6 internally or to your customers, your external facing services, ensure they have IPv6, right? Because you having IPv6, you are saving someone else from using resources on using transition techniques, right? Which we'll look at in a short while. Maybe translation, tunneling, etc., right? So just ensure your services have IPv6 enabled, right? So of course you also need IPv6 if there is incompatible software, legacy equipment. So if you have equipment that does not support IPv6, then you may need transition techniques for you to have IPv6 support, right? CPEs, old technology, yeah, you always need a transition technique to overcome this, right? So if one segment of your network does not support IPv6, then you will definitely need a transition technique, right? So for example, if your access network does not support IPv6, then you need a transition technique, because if someone is here and they want to access an IPv6 content or send IPv6 packets across this segment of your network, it can't happen, right? Unless you configure a transition technique, right? So in this scenario, you can't send IPv6 packets here across this segment of the network, right? Because it's IPv4 only. So you either need a transition technique, for example, tunneling. So you send IPv6 inside IPv4 or vice versa, right? So that's one of the scenarios. If, let's say, at your edge, your upstream does not support IPv6, right? And you've deployed IPv6 in your network. So you need a transition technique to be able to do that. Either do a tunnel via Hurricane Electric used to provide free tunnels, right, for IPv6. Or talk to your upstream to deploy IPv6 in their network so that you can have IPv6 connectivity. If maybe on the mobile device you don't have IPv4, if you're doing V6 only, right, then you need to send V6 packets to the internet. So you need a transition technique. So if the core of your network is V4 only, you need a transition technique to send V6 packets across the core. If your services are V6 only, and most of the biggest providers do this, right? Because they don't have IPv4 resources, so they usually deploy their servers behind IPv6 and do some translation at the edge. So your packet will come in as V4, but hit their servers as V6, because they run huge data centers, right? And there are no addresses left, right? Based for their use cases, right? Facebook, I think, does this. Even Google, if I'm right, if I'm not wrong. So again, if you have V6 only services, you need a transition technique for people who want to connect to your service via IPv4, right? So basically, as a summary, as long as you want to talk from either IPv4 to IPv6 only, you need something in between to enable that communication to happen. So there are three categories of transition techniques. The first one is dual stack. And dual stack, here we represent it with who knows this character? For those who like comics. Huh? Two? Yeah, Two-Face, right? So Two-Face, you can see the guy has a good side and a bad side, right? So it does not mean that IPv6 is the good side and IPv4 is the bad side, right? So dual stack, when you talk of dual stack, who knows what dual stack is all about when you talk of dual stack? Yeah, so running both IPv4 and IPv6, right? So dual stack basically means that you will have IPv4 and IPv6 across the entire path, right? From the source to the destination, right? So it means that on your laptop you have both IPv4 and IPv6 at the core of the network, IPv4, IPv6, at the edge, both IPv4, IPv6, upstream supports both, right? So you can be able to have reachability over both IPv4 and IPv6. Tunneling means that you are encapsulating one protocol inside the other one, right? So you can tunnel IPv6 inside IPv4, right? And the other way around also works, right? You can tunnel IPv4 inside IPv6, right? Then finally, we have translation. So translation is the same way as if I don't understand a certain language, I'm going to need a translator between me and you, right? If I can't speak your language. So someone will be receiving my communication and translating it to you, and then vice versa, right? Again, it goes back to IPv4 and IPv6 are different, right? So the headers, as we saw, they are different, right? So you need to translate the header from IPv4 to IPv6. You also need to translate the addresses from IPv4 to IPv6. So that's translation in a nutshell. Dual stack has an advantage and a disadvantage. The advantage is that it's easy to roll out, right? Dual stack. You don't change anything in your network, right? You just add v6. So at the edge, you add v6. At the core, add v6 on top of IPv4, right? But there's a disadvantage with dual stack. Anyone who can think of what the disadvantage is of dual stack? So it's easy to implement, first of all, right? It has few barriers of implementation. As long as the devices support IPv6, then it's easy to roll out, right? But it has a disadvantage. Anyone who can think of a disadvantage of dual stack? Yes? It can drain the resources. No. So like we said, just because you're running two protocols does not mean that the resources will be double, right? Usually, in terms of resource-wise, it's usually negligible, right? It won't be a huge jump, right? The only thing you need to be mindful of maybe is at the edge when you're doing BGP, if you receive the full BGP table, right? Because you'll also be maybe receiving the full BGP table for IPv6. So your router needs to be able to handle that, right? But in terms of resource-wise, it's usually typically stable. Yes? Vulnerabilities to attack. How? So that's a very important point, but it's not a disadvantage of dual stack, but it's a very, very important point, right? Because we said, picture IPv6 and IPv4 as two separate pipes, right? Right now, your IPv4 network is secure. You do all the security policies, right? And everything is secure. What usually happens when people deploy dual stack, you'll start configuring IPv6, but forget to do the security policies, right? Meaning that the security policies only apply to IPv4. And as we'll see in a short while, IPv6 is usually preferred, right? When you're connecting, if you had IPv6, it will be preferred. So meaning that the security policies you've done in IPv4 are useless, right? Because people are using IPv6 by default, right? It also happened, some people will deploy IPv6 to their customers and forget to integrate the billing system. So for a few days, you see that customers are using internet for free because people forgot that IPv6 is a different protocol and the same policies that are being done on IPv4 needs to also be done on IPv6, right? Yeah, so it's a very important factor for all of us to know, but it's not a disadvantage, right? Mm-hmm.
think the disadvantage will come in because you'll be forced to learn. When if you're saying you're receiving IPv6 traffic,
Mm-hmm.
and this side your internal network has the IPv4, and vice versa, you'll be forced to learn. So your traffic will have to go through a NAT.
So that's not a disadvantage because we are assuming that currently your IPv4 network is running as it is with NAT, with everything, right? And then you add IPv6 on top. And remember with IPv6, you will not do private IPv6 and public IPv6. So it will just be public everywhere, right? Yeah. So NAT is not a disadvantage because it's already running with IPv4, right? There's just one small thing. I don't know. In terms of, yes.
Troubleshooting may be difficult because you have been all going together. Problem might happen.
Yeah, so exactly. Troubleshooting, right? Because now you're running two protocols, right? So anytime there's an issue, you need to troubleshoot both protocols to know which one has the problem, right? Either IPv4 or IPv6. And also in terms of maintenance, you will be maintaining two protocols, right? So of course the advantage, according to me, the advantage of running dual stack outweighs the disadvantages of troubleshooting etc. because it's easy to do, right? But it's something you need to consider. Anytime there's an issue, you need to troubleshoot both protocols. Something that people do, which I recommend you should not do, is turning off IPv6. When there's an issue, the easiest thing that people do is, maybe it's IPv6, they switch it off because they don't want to understand, troubleshoot what's going wrong, right? So many networks, we've seen this, right? You'll deploy dual stack, and then whenever there's an issue, you turn off IPv6. So I don't recommend that. So always troubleshoot, try and find out what's going on, and fix it. So any questions on this? So let's look at the categories. So we talk of dual stack. So there are several transition techniques which you can actually implement, right? So there is dual stack, of course, which you said you do both IPv4 and IPv6. Then there is a transition technique called dual stack lightweight 4/6, MAP-E. We'll not go into details with all these transition techniques. All this, if you go through the course and also the gold level, right, we go into much details in these transition techniques. So those four, they involve tunneling. So basically tunneling, you'll be sending IPv4 inside IPv6. Then the others, the rest, the two, MAP-T and 464 XLAT, these ones involve translation, right? So you'll be translating from IPv4 to IPv6. So with dual stack, like we said, you run both IPv4 and IPv6, and then DNS will determine which protocol will be used, right? So if your laptop has both IPv4 and IPv6, and there is full reachability over both protocols, let's say to youtube.com, right? DNS determines which protocol that will be used, right? Either IPv4 and IPv6. And like I said, IPv6 is usually given a slight head start in milliseconds, right? When DNS resolution is being done and the connection is being set up. So there's a protocol there's an algorithm called Happy Eyeballs, right? So Happy Eyeballs is all about the end user, right? So when you're looking at your laptop, your eyeballs need to be happy, right? And because the algorithm tries to prevent user noticeable delays, right? Because let's say if you want to access afrinic.net and then the page is loading, you'll get frustrated, close the window and move on to something else, right? So that's what this algorithm tries to do. So long time ago, it used to be, if you have IPv4 and IPv6, you try to initiate the connection with one protocol, right? So you start with maybe IPv6. And then if IPv6 is not working, come back to IPv4, right? If there's an issue, then there's going to be a noticeable delay, right? So this algorithm tries to prevent that. So how does it do it? Let's review. So let's say you're on your laptop and you type example.com. So example.com has both IPv4 and IPv6, right? So when you type example.com, hit enter, the first thing that will be done is DNS, right? We need to know the IPs of this server, right? So we'll have two queries being sent out for the A and the quad A record, right? And these ones will be sent simultaneously at the same time, right? But usually IPv6 gets a small head start in milliseconds, right? So that's why, based on even the comments about security, IPv6 will always be preferred slightly, right? And if you deploy IPv6 in your network, most of the time you find that the traffic will switch to IPv6. Most of the traffic will be IPv6 because IPv6 is usually preferred. So the DNS server will reply with the IPs, right? Again, simultaneously, we get back the IPs, and then the TCP session will be initiated using both protocols, right? So you remember the three-way handshake, right? The SYN will be sent. The server will send back the SYN and the acknowledgement, right, over both protocols. And then the host will initiate the connection with IPv6, right? The acknowledgement will be sent via IPv6. This is assuming the IPv6 path is working properly. If there's an issue, then the host will initiate the connection with IPv4. So in this scenario, the user will never notice that there's an issue with any of the protocols. There'll never be a delay when the connection is being initiated. But basically, as a summary, dual stack depends on DNS, right? So when you're on your laptop and you want to access maybe youtube.com, the queries that you get back, the entries, the DNS records that you get back will determine which protocol to be used. And most of the time, IPv6 is given a slight head start. So any questions on dual stack? Any questions or clarification? So the next transition technique is what you call dual stack light. So dual stack light is a variation of dual stack whereby instead of using dual stack everywhere, some parts of your networks will be IPv6 only, right? Because with dual stack, you still need IPs everywhere, right? And remember, we have lack of IPs, right? So with dual stack light, you have segments of your networks that do not have IPv4. And for you to transport IPv6 packets or IPv4 packets across those IPv6 only networks segments, you need a transition technique. And that's dual stack, which is one of them. So dual stack light has two elements. So it has what we call the B4, which is the CPE, right? So the customer premises equipment, we call it the B4, the basic bridging broadband. And then you also have the address family transition router. So this is the device in the provider's edge or in the provider's network, right? And then dual stack light will combines tunneling plus NAT, network address translation. So one takeaway from this is you need to know in terms of dual stack light, the CPE is called the B4, the basic bridging broadband, and the device in the provider's network is called the address family transition router. So let me show you a diagram. Before we look at the diagram, so dual stack light will involve a NAT table. So most of the time, dual stack light will be implemented on the device that does CG NAT or carrier grade NAT in the provider's network. And the NAT table will be extended to capture the tunnel IDs or the various CPEs, right, where traffic is coming from each of the CPEs. And then it also has the element of address sharing. So for all these transition techniques we'll be looking at next, right, you'll have an IPv4 only service on the internet, right? Maybe a good example is x.com, or formerly Twitter, right? It's IPv4 only, meaning that you cannot access that website from an IPv6 only host, right? And again, most of our websites should fall in that category. They are IPv4 only, right? Then you also have another service which is dual stacked. For example, YouTube. So YouTube, you can access YouTube from an IPv6 only network, right? You can access it from an IPv4 only network. It's dual stacked, right? Then you have your segment of your network, which is V6 only, right? So this section here is V6 only. So you can already start picturing this. If this is V6 only and you want to access x.com, something needs to happen here to transport the IPv4 packets, right? Inside this section of your network, which is IPv6 only, okay? So in the customer's network, in the provider's network, we have the AFTR, and then in the customer's network, we have the CPE, and this segment can be dual stack, right? It can have both IPv4 and IPv6. So if a customer wants to connect to YouTube, like we said, it's IPv6, right? They can use IPv6. The packets will be sent across the provider's core or access network without being touched, right? Since it's IPv6 fully, right? Till it gets to the server. The problem comes when this customer wants to talk to x.com or they want to access x.com, right? So the packets are IPv4, start off as IPv4, right? When they get here, this segment is IPv6, so something needs to be done, right? So with dual stack light, we encapsulate IPv4 packets inside IPv6 so that they are transported across the core or access network, and then at the AFTR, the IPv6 packets will be removed and we are left with IPv4, right? And V4 will be sent to the internet. Same thing happens when coming back. So this is just a big picture. You don't need to understand the finer details of how it works, especially for this level. You just need to know if there's a segment in your network that is V6 only, you need a transition technique to send IPv4 packets across, right? That's what you just need to remember. And for the various transition techniques, you need to remember that you can do dual stack, IPv4 and IPv6 everywhere. You can do dual stack light, whereby you have a segment of your network to be IPv6 only, right? And if that segment is IPv6 only, you need to transport IPv4 packets across it, right? So that's when you deploy this transition technique. At this section of the network, you need to encapsulate or tunnel IPv4 packets inside IPv6, right? When they get to the edge or to that device, the IPv6 packets, the header is removed, you are left with the original IPv4 packet, which is sent to the destination, right? So I hope you have that picture, right? whenever we talk of transition techniques, and specifically tunneling with dual stack light. So if I ask you a question, I may give you a diagram like this, and I ask you, with dual stack light, what protocol is running in this segment of the network? So you need to remember that in the provider's network, some segments are IPv6 only, right? On that segment, on the internet can be IPv4. You can have services running IPv4 and IPv6, both of them, right? Same thing, in the customer's network, you can have both IPv4 and IPv6. The key thing with dual stack light is in the provider's network, they have a segment that is only IPv6, right? Yeah, so that's the only important thing you need to remember. At this level, like I said, you don't need to know exactly how dual stack light works. So you just need to have a big picture on this transition technique. So any questions? Yes. So the question is, will the transition techniques cause any network delay? What do we think? Anyone who wants to respond? Again, like I usually say, there's no wrong or right answer. It's just contributing, and then we know, yeah. Yes?
Yes, I think, but it will be very small delay.
Yeah. Anyone else? Do you agree? Yes. Yeah, so of course, since you're doing something here, right, at the edge, this CPE will get, for example, an IPv4 packet. It needs to start encapsulating IPv4 inside IPv6, right? And then at the edge on this device in the provider's network, we also need to remove IPv6 and then send. Even before sending, you map where the packet came from. You see the same way NAT happens, right? The source, destination, you need a binding table. Then send the packet. When it comes back, same thing needs to be done. Check the table, know which address to use, send it back. Okay, so of course, doing that introduces some delays in the network, minimal delays. So that's why, again, like I said, if x.com or even you, if your website has IPv6, you're preventing someone from doing all this, someone in another network from doing all this, right? Because if the website had IPv6, you just initiate the connection over IPv6, right? So there will be no need for tunneling or translation, right? So that's why it's important for your website to also be IPv6 ready, right? Or have IPv6 deployed. Hope it's clear, right? Okay. Any other question? So if there's no other question, the last thing we'll look at is NAT64. And with NAT64, it solves this problem, right? Where we have an IPv6 only network and you want to communicate or talk to an IPv4 only service, right? NAT64, right? You're translating from IPv6 to IPv4, right? With the NAT that you're used to in IPv4, it's usually NAT44, right? NAT44, from private to public. And if you're a large provider, you can do large-scale NAT or the CG NAT. You do NAT444. You do NAT 2 times, right? So with IPv6, you translate from V6 to V4 and vice versa, NAT64. So NAT64 has some important elements. So first of all, you'll have an IPv6 only client, and then you have an IPv4 only server. So V6 and V4 can't talk to each other, right? So that's why you need these elements here. You need a translator to translate from IPv6 to IPv4 and vice versa. Then you also need a DNS64 resolver. So let's see how this works. And I always say I don't like this diagram because there's a lot going on here. The first time you see it, you can't tell what's going on, right? But let me explain step by step. So here you have a host that is IPv6 only. And then example.com on the right, it's a server that's IPv4 only, okay? So we need to figure out a way to get this to talk to each other, right? So the first step that happens is the host, you'll type maybe on, this is your laptop, you type example.com, hit enter. First thing is DNS, right? Since you're in an IPv6 only network, you're going to send a request for the code A record, right? Example.com. So you have a DNS64 server that's been set up in your network, right? Internally. So if it's the first time you're making this request, the server is going to do a recursive resolution, right? So when it queries for example.com, it gets back an IPv4 address, right? Because example.com does not have IPv6. So this server here is critical. When it gets the IPv4 address, it's going to create a code A record, or to synthesize. The right word to use is synthesize. So it got an IPv4 address, so it's going to craft an IPv6 address, and to do that, it will use a prefix 64FF9B, or you can even set up your own prefix. But the main thing is that prefix is a /96, right? And remember, how long is an IPv4 address? 32 bits, right? So that's why the prefix is 96 bits. If you combine it with the 32 bits, you'll get 128 bits, right? So the DNS64 server uses a /96, which can be this well-known prefix, the WKP, or it can be something you configure yourself, right? But it's a /96. Then it creates an IPv6 address, right? So if you check this out here, so we use the 64F blah, 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 and then we have the V6 address converted to hex, right? So this address corresponds to that IPv4 address, right? So when this host gets back the DNS response, it thinks that that server has IPv6, right? But essentially, DNS64 is the one that crafted an IPv6 address. So when it initiates the communication, it will use its source IP as the source, right? The destination IP will be what it got from the DNS64 server. And then at the edge, you have the NAT64 device, which will now do the translation from IPv6 to IPv4. So also this NAT64 device knows about the well-known prefix, right? That's prefix in green, right? So when it receives a packet that has that prefix, it knows that it needs to remove this and convert this address here, this section, into decimal to get the IPv4 address, right? So from that point, number 7, you see the source IP comes from its own pool. The destination IP is the original IP, right? It gets to the server responds. Again, the NAT64 device does the translation, right? Translate the packet from V4 to V6 and also the addresses, and then sends back the packet to the host as an IPv6 packet, right? So that's how NAT64 and DNS64 works in a nutshell. So any questions? Like I said, you don't need to understand this in depth, right? For a level, you just need to know that there are several transition techniques that are available. You can start by doing dual stack, which most of the people always start with. If you want to go one step further, you can do dual stack lite, whereby you remove IPv4 from segments of your network, right? You can do dual stack lite, you can do 464 XLAT, MAP-T, MAP-E, all the other transition techniques, right? You go one step further. Then for translation, there is NAT64 and DNS64. So any questions when we talk about transition techniques in general? Any questions? Yes.
Maybe if I might ask. So with regards to that 64.
Mm-hmm.
So if at all I'm a host, so we need to do all this. Is it my ISP or the content provider?
So remember this scenario, it's the person doing the configurations internally in the network. Remember for NAT64 will work in, it doesn't work in a large scale level, right? Yeah, but someone needs to configure this NAT64 device at the edge, which is you, the provider, but not the user, the end user or the customer, right? So the provider will configure this, configure that, right? And so that when packets are being sent from the IPv6 only network, everything will be done properly, right? Yeah. But there's a disadvantage with this NAT64, right? Who can think of something that may go wrong here? Yes.
Mine is more of a question. The DNS64 server and the NAT64 server, do they keep in touch or they have an algorithm that they share so they know how to synthesize?
Mm-hmm.
This,
Yeah, so that's a very good question. So the question is, the DNS64 server and the NAT64 server, are they in sync or do they keep in touch? So usually you will configure the DNS, and DNS64 server is just a regular server, DNS server, right? And if you do the actual configuration, it's usually, last time I did this, it was 2 lines, basically. You add 2 lines. You add this prefix, and then another line to enable DNS64, just 2 lines. But to answer your question, the same prefix that you configure in the DNS64 server will be configured on the NAT64 device. That prefix is what determines whether NAT64 will be used, right? That's how you sort of like sync, but it's not, how can I put it? There's no protocol. These two don't even need to communicate, right? It's an individual DNS server as long as it has that prefix /96 configured. The same prefix will be seen from, the host will receive an address with that prefix, and then this device here needs to know that prefix, right? So you need to configure the same prefix over here so that when this device here gets a packet with an address that has that prefix, it knows what to do, right? Yeah. I hope it answers your question. Yeah. Any other question? My question was, there is something that can go wrong with this, right? Who can think of it? Oh, yes.
Can like DNS64 fail to create an IP address, explicit address?
So technically, as long as the DNS64 server knows about the IPv4 address, it should create or craft an IPv6 address. Unless it doesn't get back a response from the server, right? If you do a code A request or the A request for example.com and there's no response, then maybe that server is not available and it will not do the connection, right? It will not create the DNS request. Any other? Yes? What can go wrong here? Yeah, so the NAT64 translator can fail. Even the DNS64 server, it can fail. If it fails, then there's no connectivity in this scenario, right? But there's something else apart from that. And if you recall on Tuesday, if you recall, Patrick mentioned it, Patrick from Work Online. And it's in relation to, the developer is not here. It's in relation to how you develop, yeah. Yeah, exactly. Exactly. Remember, all this depends on DNS, right? So instead of typing example.com, if you're on the host and you type 192.0.2.6, it will never work, right? Because all this process depends on DNS. So the hard-coded IPs are called literals. So when you're working with literals, if there's an app, let's say if you're in this IPv6 only network and you have an app that has hard-coded IPs in it, right? Then it's never going to work, right? Because NAT64 and DNS64 depend on DNS, right? Because a query needs to be done, and then DNS64 needs to synthesize based on the response that it gets, right? So when you type in a hard-coded IP, it will never ever work. So any questions on this? So of course, I'm trying to resist not going into too much details. And maybe I'll give this as a homework to you. If you go through the transition techniques course, right? Usually and realistically, you cannot deploy, and even with the thing about hard-coded IPs we've just talked about, it's very hard to deploy NAT64 and DNS64 on its own, right? Most of the time, realistically, you'll find that there are other transition techniques, and the most common one is what you call 464 XLAT, whereby you do double translation, right? Instead of using NAT64 and DNS64 alone, you're going to translate from IPv4 to IPv6, and then from IPv6 to IPv4, right? You do double translation. With that mechanism, it means that if someone is using literals, it will also work. But NAT64 on its own, then it has that issue of literals, and realistically, you'll never see NAT64 deployed on its own. So any questions? So I'll encourage you to go through the transition techniques course, right? Because it goes in details on all these transition techniques. Any questions? So if there are no questions, yes. So the question is, we talked about a scenario whereby someone is on IPv6 and they're trying to access maybe an IPv4 service. So is there a scenario where it's the other way around? So yes, the answer is yes. And the most common use case for that is for people who run services, right? So some people run, there was one diagram here. I can't. This one here. So there is a chance that we have some providers that usually run v6 only services. So you see from this scenario, if you're connecting from IPv4, you need to translate from IPv4 to IPv6, right? So this is one of the scenarios whereby it's the other way around. And like I mentioned, Facebook, I think even Google usually do this in their data centers, right? So they run v6 internally, and then they have load balancers which do translation of from v4 to v6. Yeah. So your question is IPv6 performs.
Because when you try to run it locally, like a project, it fails.
Mm-hmm.
And then if you leave your ASCII, it recommends IP. Why is that?
Does it recommend IPv4? Because unless you start maybe doing things like checking the round trip times to know what's happening, actually troubleshooting, does it do the recommendation based on the actual connectivity, or is just because, you know, someone may say we recommend IPv4 because maybe there's an issue with IPv6 or how the platform runs on IPv6, you may encounter problems. So they just want to avoid using maybe IPv6, I don't know.
Okay, the interface first was about the update they had recently.
Uh-huh.
They were the sections, ORM, and the connectivity. When you look at Scopus right now, it's a different version. So when you copy the URLs to put maybe into the environments of the project, they will fail if you use the IPv6 version. They will fail. And then when you use IPv4, they come out so perfect.
So maybe I think it's a problem with the platform itself. That's what I'm thinking. Because if it's in terms of connectivity, I'm just thinking out loud. Let's say if you're connecting from your device and you have both IPv4 and IPv6, so I suspect maybe it's just how the platform has been set up, and it maybe prefers connectivity via IPv4 versus IPv6. That's what I'm thinking. I don't know the platform, I don't know how it works, but that's roughly what I'm thinking. Because if it was, let's say in terms of connectivity, if you had issues, let's say if you are seated here and you want to connect to maybe youtube.com, let's say if you turn off IPv4 and connect via IPv6 and notice that it's taking longer or it's not working, you know there's a problem with IPv6, right? If you enable IPv4, do the same thing, and realize it's working faster, then you know there's a problem with IPv6. Yeah. But maybe if you get time, I can have a look and see, and then maybe I'll understand better. Yeah. Okay. Any other question? But regarding that, always troubleshoot, right? Before you dismiss IPv6 and shut it down and forget about it, always troubleshoot. Because we've seen it happen, right? And it may be a genuine thing that's happening with IPv6, right? Because obviously, if your network was running properly and then you introduce IPv6 and you start seeing challenges, then it means obviously there's an issue with IPv6. So instead of turning off IPv6, take the time to troubleshoot and try and find out what's the problem. Usually, sometimes, most of the time, you'll find that it's issues of MTU. Maybe the MTUs are not properly set, right? in your network, right? So, but troubleshoot before dismissing. Any other question? Yes.
At that max 64, can you get overwhelmed with all admissions within the network?
Yes, it can. It definitely can. So for large providers who implement this, you'll find that they implement multiple instances of that NAT device. Yeah. So it's never only one device. It depends with the load, right? Yeah. And I'll recommend that you read or go through the course, because the realistic transition technique you'll do is not NAT64, but something called 464 XLAT. 464 XLAT is NAT64, plus you introduce another translator on the edge device, on the customer's device. Android, Apple, the iPhones, they have that functionality. It's called the client-side translator, the CLAT. Even Windows, actually, this year. So Windows also have a translator, client-side translator. So the provider will have a NAT64 device. Your laptop will have a translator. So your laptop will be translating from IPv4 to IPv6. Then your provider will translate from IPv6 to IPv4, right? A good example is, for me, when I'm in Kenya, there's an operator called Safaricom, the biggest one. Sometimes I can switch off IPv4, right, in my settings, right? The APN settings, switch off IPv4, and I run IPv6, and everything works perfectly, right? I don't miss anything, right? So again, the main point is that people are deploying IPv6. You should not be afraid, and if you encounter issues, don't give up or switch off IPv6. Any other question? Yes.
I didn't get an answer properly to the last question. The danger of NAT64. The question.
The one I asked, it's the literals, the hard-coded IPs, right? Because if someone types in the IP manually, or if the app has literals or hard-coded IPs, NAT64 and DNS64 will not work, right? Because it all relies on the query, right? When you type maybe example.com, a query is sent out, the DNS64 server gets the IPv4 address and then creates or synthesizes a code A record for you, right? So you see, if you type in the IPv4 address, it will never work. Yeah. But it will work if your device has a translator. So that's why I say NAT64 on its own, it's never deployed, right? So if your device had a translator, let's say if it's your phone or your laptop, so instead of, if you type the hard-coded IP, your laptop will translate that IP and the packet from IPv4 to IPv6 before it hits the provider's network, right? Then at the edge, the NAT64 device will translate again from IPv6 to IPv4. Any other question? Yeah, so if there's no other question before we break for lunch, but basically that's the end of the course, right? You've reached the end of the training. So now the only thing left is for us to do the exam. I'm waiting for a response for the guy who manages the lab. If it will be available, we'll do one of the labs in the afternoon. If it's not set up, I'll organize, we do the practice exam today. That mock exam, right? We do it in the afternoon. And then tomorrow morning, we review it. And then you can do the final exam, right? So for now, what I'd like us to do before we break, so head over to this spreadsheet. So you can, in case you're not on it, I can see some guys already on it. So visit this link on your laptop, bit.ly that 4FZWGZN. So of course, in this sheet here, links, there is the link to the slides, right? If you want to review. What I want us to do, once you get access, click on this sheet here, attendance. And then when you navigate to attendance, I want you to fill in your details there, right? So pick an empty slot, right? Click on an empty cell anywhere and then fill in your first name, last name, organization, email. And then this should be how you want your name to appear on the certificate, right? So pick an empty blank slot, right? You can even do it down here. Just pick a blank row or cell, then enter your details. So this is the URL for those who are not yet on this spreadsheet, Google Sheet. Yes, just pick one cell. Click on any random, you can scroll down. Yeah, and then type it. Yeah, just type it. Yeah, first.
Are we using the same email used for enrolling into the course, or we are using ours?
Use the same email used to enroll to the course. But anyway, this one can be different if you want it to be different. So if there's no other question, we'll let you know when lunch is ready. So in the meantime, you can review the content that we've been going through. And if you have any question, please let me know. Some questions in the final exam, that's when in the exam. So yeah, when you're in the e-learning platform, ensure you take the final exams, right? Because some questions in the final exam are also there in is the exam that you do tomorrow, right? But again, like I usually say, it's not even about the exam itself. You're just testing yourself whether you actually know the content, right? So whether you do the final